So in this session, we'll mainly talk about now again a thread program, okay, using pthread library, which would be creating a thread, and we'll be passing one parameter to the thread. Thread will compute the result and will return back to the program. Okay. So now this program would be for computing the factorial. So let us try writing the function. Dot C. So we have to add header files. So include stdio.h hash include stdlib.h and similarly hash include pthread.h. Now we'll write a function for the thread computation. So say factorial, which is returning void now, but we have to return integer value. We'll take care of that part, and the parameter again is required to be void y. And so we'll be writing that function definition here. So now first of all we'll complete the main integer main. So pthread t variable name as thread. We will have one integer. We'll read this number, and as we are going to compute the result, okay, in the thread, and we have to save that value so that the thread and the original program creating the thread should get the values from that location. So we'll add here an address which would be a shared value to store the result. Now we will create the thread. Pthread create ampersand thread. We are not passing any attributes. Now we will be talking factorial. So that this is the name of that function. And then we will pass address of that number. Now once the thread is created, so if it doesn't return 0, then ultimately we'll write a p error function. Pthread create failed and then exit 1. Similarly, now this thread is created, correct? Say, now we have to join that thread and we have to take return value from that thread. So if pthread join the same variable thread id, now this would be a returning value. So thread result. If this thread join is called and if it doesn't return 0, that means it failed. Right? So p error pthread join failed. exit 1. Correct. Now, as would we getting the return value into thread result, we have to now print that value. So we will use a printf statement and we will print the value. So printf thread computed the factorial as %d /n, and now we have to print that thread result. Then, like, as we would be allocating this shared memory, okay, this thread result, which will be shared with the a.out main program and the thread created. So we have to free that. We will free that, and then return 0. So this would be our main function. Now we have to write the factorial calculation function. So here, let us first convert this input argument to a number. Arg. Now we have to store that in a shared variable. So we will allocate space for it. So say result. Okay, and now this result we are going to use a malloc, which is of type integer. So size of int. Now if this result is null, that means memory is not malloc. What are the 4 byte size memory? If it is not allocated, then error malloc failed, exit 1. Now here we could have written exit 1, but instead what we'll do, as it is a thread, and if in the thread, say your malloc function fails, then we'll be adding pthread exit function. Exit null. Okay. Now if everything is fine, in the sense, suppose thread exits, if memory is not allocated, but suppose memory is allocated, now we have to compute the result. So let us say the factorial we are going to store with the variable result, we will initialize it with 1. Now as we already took the value, so let us declare one variable here as an index, integer I, for I is equal to 1, I less than equal to the variable where we took that past integer, and I plus plus. Will compute result is equal to result multiplied by I. Fine. Now here this factorial would be computed. Now we have to return the result. Return result. This would be return value, and then the thing is complete. So here what we did was we wrote this factorial function, okay, which is taking an argument. So we are preserving that argument into num by typecasting it to integer value. Okay, then we declare these 2 variables. One is meant for index, the other one is meant for storing the result. For that result, where exactly we are going to store, we have allocated memory of size 4 bytes. Okay, because integer is of 4 bytes. So if allocated memory is not allocated, then that means malloc failed. So we will be exiting from thread. So that's why we wrote this pthread exit. Otherwise, compute this. So as we are storing factorial result with result variable, so we would be assigning initial value to it as 1. Then for I equal to 1 to I less than equal to num I plus plus, we will compute the factorial by multiplication. So I would be increasing till that, then automatic calculation will be done. And so let us save this code. We'll try to see if errors are there, then we will try to resolve the errors. So gcc-m32 thread factorial.c. Correct. So we computed thread factorial and execute. Now, as we are not asking any that user to input any value, so that's why display the value as one. So we'll try to write that code and see like whether are we reading that integer. So here we won't read this num. That's why num value is taken as 1, and the result is assigned 1. That's why it is the case. So we'll write here printf enter value to compute factorial, and then we are writing scanf %d and %num. Okay, let us save. Now let us execute. Now let us say we are writing 5. Fine. We are writing 4. We are writing 7, 6. We are writing 7. Fine. Now again, like as what we did was the thread is returning the value. So we'll try to see if we can get the success in terms of seeing the output of PS command with thread entry appearing. Okay, in PS output. So max thread underscore factorial.c. So we'll add simply one scanf here after the computation is done. Okay, scanf %d and %num. Let us compile. Run. So here we are giving 5. Now it is waiting. So let us write ps dash ejh. So a dot out is 18915. 18915. Okay, 18915. Sorry, it is 18915. You can see two things are added. Now as we added that there, so initial value is taken. Now if I talk, so if I put any value, because we added that scanner to wait for some time, so that's why it is the case. Now one can remove that scanner and add let us see if it works. We added sleep. Let us see 5 19543. Now it's already done, so we will miss that value. Let us execute again. 4. So 19598, 19598. So that is already finished. We can add there 20. So that it can wait for a while. GCC 5 grep a dot out. Now here 19693. You can see the two values. Right. Now it will return the factorial and then done. So here what we saw is, like, from the program, when thread is created, to the thread value is passed, we are computing the value in the thread and then result is returned. So the main function here is this, okay, to compute the factorial. And so we took integer, okay, then we converted, we passed integer there as an argument for a void, then we type casted it, we created a space using malloc, then we check whether it fails. If it fails, then we are exiting from the thread. So pthread exit we used, otherwise result is stored with the result variable. Okay, and then we computed result multiplied by index, which is running from I equal to 1 to num, and then we return the result. And in main function, in join, pthread join, we are using that, and then, like, the result is computed. So it will be fetched here from that location, and then this thread result variable will be holding that returned value. So this is how thread can compute the result and return the value.